in binary outcome variable. The moment change analysis, we always remember the McNemar's test, the paired chi-square, McNemar chi-square test, the change analysis. Basically, the McNemar test deals with the B minus E. Some of you remember the B minus E. This cell is called a B cell. This is called a C cell. So basically, the difference between the two is same or not. That is what the concept between the two tests. What does it mean? Say, for an example, if the question is whether Dr. 1 and Dr. 2 evaluating whether someone has a STD or not. Same 100 patients went to the Dr. 1 and went to Dr. 2. So what do? You compare, is there any association, is there any difference between the two doctors? So you compare B minus C, that is, the B and C should be equal, that is your null hypothesis, whether equal or not. That is a concept in B minus C. But here, when you have 2 time points or more time points, we are interested baseline versus time point 1, baseline to time point 1 versus time point 2, and so on and so forth. We are not interested in testing whether B equal to C. We are interested in computing the change analysis. How much is a change in this cell and how much is a change in this cell? This is what are variables of cells of importance. This is, if you say for an example here, this is time 1 and time 6, 2 groups. The difference basically provides an indication of the difference between the changes in the opposite direction. That is a B minus C analysis, McNemar's chi-square test. As I said, that our interest is that whether they are equal or not. B minus C, that is a whole square divided by something, some formula, B plus C whole square something. The whole idea is whether they are the same or not. But we are here in the change analysis. We wanted to capture how much is this change over a period of time. So total change over time is to calculate proportion of subjects who change from one group to another. So this is what is your, say for an example, someone who was in 0 low cholesterol level changed to high cholesterol level. Okay. When you come here, how many of the subject from high cholesterol level to low cholesterol level? This is what our interest is. Because we are interested in change analysis. We are not comparing whether the time 1 is better than time 6 or whatever, like as we said in the STD study. So the one doctor is able to diagnose much more than the other doctor or not. That is not the question. Low cholesterol to high cholesterol or high cholesterol to low cholesterol, on average, what has happened? That is our interest. Therefore, we need to compute the change over a period of time. This is what I said in the McNemar's test. This is total changes this much. That is not our goal. This is, so each time these are all our time points. Say for example, 1 versus 2, 2 versus 3, 3 versus 4, and so on and so forth. So the multivariate extension of the McNemar's test is that Cochrane test. So I'll come directly to the GE analysis of dependency adjusted regression coefficient. So let's see this. So basically, what is clustering concept which can go on in a GE analysis when the outcome is binary, yes or no? In sports, if I get injured, for an example, in my knee, I am more likely to get injured in the next match and so on and so forth. So therefore, one injury is likely to cause more injuries later on. So therefore, my observations are clustered. Similarly, many categorical variables, you can think about it. So it is like our continuous variable, high cholesterol, people with high cholesterol likely to have high cholesterol over a period of time. So similarly, who had injury, likely to have injuries in the future. So when you observe them over a period of time, that information is correlated, okay? And so exactly the same structure, etc. What you need to do is, this is the code. If somebody uses Stata, then they can use this code. So because it's a very expensive software, we use this. See here, the family is binomial. It is not normal. The code which we use this as we say that outcome is binomial, not continuous. Okay. Otherwise, it is exactly same. The ID is a clustered variable. ID is a subject variable, and correlation structure is exchangeable. Okay. When you write a paper, they will not ask you how did you choose exchangeable correlation, how did you choose autoregressive and all. So conservatively, that we use exchangeable correlation structure is very robust. It doesn't get changed by when you change the right correlation structure. So therefore, it is understood all over the world that exchangeable correlation is the standard structure which could be used in, because they know the difficulty of diagnosing the correlation structure. So here, this is just the Jyoti, is it a naive analysis? I don't see a time in naive analysis. Is that right? Yeah. Do you know what I'm saying by saying that naive analysis? Morning we showed you this, the gender versus t-test and the regression analysis. Do you understand? What is the equivalent type of analysis here? Because categorical data, gender is bivariate. What kind of simple analysis you would do in chi-square? Simply you do the chi-square test. And if you don't interact it with the chi-square, simply you do the logistic regression analysis. Both are going to be same. G analysis with a chi-square with a variable in the model. It is simply same, unless you interact it, okay? So this is, you need to interact it with the time. This part is missing here. So what you can do is, if you don't have a specific question in this analysis, you don't know how to deal with that. Just still you need to, if you wanted to do the G analysis, is no different from just the we need to do the simple analysis without specifically saying that exchangeable correlation structure and regression logistic regression analysis with the various time points. Don't specify any correlation structure, which is a naive analysis, and see how much is the difference happens in one of the particular variables that you are interested in. What are the variables which we are interested in? So, for example, smoke and gender. I'm interested in these two variables, adjusting for body fat or time, baseline fitness, and body fat. Here, unfortunately, body fat is a time-dependent covariate. Please remember, I'm using the word covariate. That also changes over a period of time. Therefore, I am interested in this analysis. What happens in the body fat over a period of time, because that is also a time-dependent covariate. Outcome is also time-dependent covariate. Outcome is a cholesterol, which is bivariate in nature. Okay. So if you do a naive analysis without structuring or capturing the correlation structure, and you can study the change in SE in this analysis as compared to naive analysis without specifying a correlation structure. Do you understand what I'm saying? Okay. Say for an example, even though I have structure which is measured over a period of time, If I don't specify the structure and simply do the analysis, what is my sample size? Supposing I have 100 subjects measured over 5 time points, 500 observations I have. Okay, do you understand? If I do G analysis, what would be my number? Naive analysis will deal with the 500 observations because I am not specifying the correlation structure. The G analysis will deal with the 100 observations and how many observations per subject is 5. So as I told you in the morning, that the body fat, which is a repeated measure, will have a lower standard error as compared to the naive analysis. So therefore, more likely to get significant result as compared to naive analysis. That is the advantage of doing it. So this is using R code, the same thing, unstructured, exchangeable, and so on. You can do this. The G is quite robust for wrong choice of correlation. That is what I said. We are saying that don't worry too much about what correlation structure do I select. If you're very specific and the perfectionist, just do this individual correlation structure and see which one gives you lower likelihood ratio. So this is here. The question is whether we'll do, you have to have binary structure outcome variable measured over a period of time. The rest is, you can have a binary outcome measured over a period of, binary covariate measured over a period of time. Say for example, smoking changes over a period of time. People change their behavior when you go every 3 months or every month, and so on and so forth. Therefore, it is changing covariate, time dependent covariate. So you can model it. Otherwise, it is, except that you need to specify this is a binomial, the distribution is binomial, and so on. So we'll do some problem and see whether you are able to repeat it and see. This is now say for example, how many, I don't know how many of you remember the McNemar's chi-square, B minus C. When you say B minus C becomes 0, that there's no difference between the two doctors or whatever. But here the analysis is interest is here the change. How much is it? How many people moved from this point to this point, this point to this point? So therefore the total changes of interest. So that has to be captured very carefully. There is a small difference between the two analyses. So whenever I say, yeah, I know that the subjects are followed up over a period of time, therefore it is a McNemar t-test, a chi-square test or whatever. We may not have time to check the analysis when you do a naive analysis without adjusting for, without doing proper GE versus chi-square test and logistic regression, like what we showed for a t-test. We'll make sure that you are able to repeat the GE with the binary outcome. The data is already coded as binary outcome, that is high cholesterol, low normal cholesterol. Use this data to do this analysis. Is that okay? We'll stop at that level.